So before we move into today's content, I just want to refresh our memories on yesterday's conversation. We talked about the difference between two different types of graphs, two different lines. Proportional ones we have already spent a lot of time with in general. We know that a proportional graph goes through 0, 0 and travels in a straight line. We talked about how we can write these as equations that look like y equals something times x, and we used the variable k just to represent that number that's being multiplied, x, that is constantly changing. And then we explored this new word called a linear relationship. These graphs contain a line. They are still a straight line, but they don't necessarily go through the point 0, 0. And we talked about a term called the y-intercept, which is where these graphs intercept that y-axis. And when we look at those equations, such as y equals something times x, whatever this next number is, for example, if it's plus 1, then we know that's where it intercepts the axis. Or if it's minus 3, that's where it intercepts the axis. So we've been looking at these tables that you created in class a couple days ago. I just want to bring this back to the forefront of your mind because table number 1 in this case is a proportional relationship. And we spent a lot of time in our proportionality and proportions and ratios unit figuring out how to determine if a graph is proportional. And we talked about how to find that constant of proportionality, which is really just the unit rate. In this case, if you look at a table wherever x equals 1, that's what gives you the constant of proportionality. In this case, it's 4, because that's what the unit rate is. So every time you are just multiplying by 4 as you increase. However, now with these linear relationships, that same trick doesn't work. Because if you look at where it's 1, we now have 6. And that is not what our multiplier up here is. So our conversation today is really going to be, how can we get this number? How do we know where that multiplier or number comes from? We know that this plus 2 or whatever that other piece is in the equation comes from where the x equals 0 and that y-intercepts. So it's 2 because that's where it intercepts the y-axis. But where and why is this a 4 based on this table? Or, in the case of this equation, why do we have a 2/3 x? Again, we know that because there's a minus 1 here, that's where the point 0, negative 1 comes from. That's the y-intercept. But as we continue moving on in this table, why is it a 2/3 x? Where does that come from? So that's what brings us to the notes that are sitting in front of you. If you have those out, we're introducing this word called slope, which is really what we call this number that's in front of the x. We call that the slope because that is what is describing the steepness of the line. So slope is the steepness of a line. And really, you know what this means and have an understanding of steepness in contexts other than math, because I'm sure at some point you might have either gone sledding down a hill or biked up a hill or hiked a mountain or something where you have experienced steepness to some level, whether that was an uphill steepness or maybe steepness going down a hill and how much speed you pick up. You have an understanding of what that looks like, and so maybe you have a steepness like this, or maybe it's a more level steepness. But that's what we're talking about. How do we know what that is for a graph? So interestingly enough, when we're talking about slope, it's really written as a ratio because it's comparing how two different things are changing. So slope is written as the ratio of how the y-axis is changing. So I'm going to write that as the change in y, meaning we're going up and down, over the change in x. And I'm talking about that in terms of those y and x axes. And we're going to talk about it today as, instead of saying this over and over again, we're going to call that the rise and the run. The rise because you're either rising up or down, and then running because you are running from left to right across the x-axis. So in our equations, we use the variable m to represent this. So with proportional relationships, we use that letter k. Here you'll see something mx, and then again it's plus or minus a number, whatever that y-intercept is. We'll just call it another letter b. That's just for your notation later on. So when we read a line, which is what we're going to spend most of today looking at, just graphs, not anything else at this point. But when you read a line, we always go to the right. This isn't new because that's how we always read in English. We start reading on one side of the page and we read from the left to the right. And so the same is going to be true today as we're looking at a couple different graphs. There's also one other thing to note when we're looking at these graphs, and again, you know this in real life context. These graphs can have a positive or a negative slope, and it's similar to saying something's going uphill or it's going downhill. So a line with a positive slope, sorry about my pen mishap there, a line with a positive slope is going to slant upwards from left to right, meaning it looks like an uphill line in some capacity. A line with a negative slope slants down from left to right, meaning you're starting on the left side and it's going down the page in some way, shape, or form. So by the end of all of this, we're really talking about, and the goal is that we will be able to find slope using any of the three members of the trifecta. Today we're going to calculate it just from graphs, but like I said, all of these three members are very much so connected. So we should be able to look at graphs, tables, and equations, and all of them will give us the same information about the steepness or slope of a line. So I've got 6 examples here we're going to work through together, just figuring out how we can calculate this slope or the steepness, and then you'll try a couple on your own here later on in class. So these directions actually give it to you kind of nicely. We're going to find the slope of each line, and we're going to start with the left point, again, because we read from left to right. So starting with the point on the left, and then counting the rise, which is how we are changing directions up or down, and then the run, which is us running from left to right, the x-axis. How that change is happening from one point to the next. So the first thing I want you to notice in graph number 1 here is that this is a downhill. As we go from left to right, we are going downhill, so we should have a negative slope. And we'll see that to be true as we start calculating this rise over run. So I'm going to start as the directions said on the left point. I'm going to put my pencil there. I'm going to ask you to do the same, because when you check in with me in a few minutes, I want to see these triangles drawn in. And we're going to draw in the change in y, or the rise from this point to the next. So in order to get down to this next point down here, we need to go down 1 box. So I'm going to write a -1. That's the change in the rise. And then we need to go to the right, or run 3. So when I write this slope, it's going to be the change in y, or the rise, which is -1, over the run, which is 3. So my slope would be -1 over 3. And that number is true no matter where these points are on the graph. If you start at this point, you go down 1 and over 3 to get to the next. If you start on this point, you go down 1 and over 3 to get to the next. So those little slope triangles are telling us how steep the line is. So now as we look at graph 2, we notice this is an uphill line, so we should have a positive slope. And as we put our pencil on the first dot on the left-hand side, we need to calculate the rise first. So how much are we going up or down to get to the next point? In this case, we're going up 3 and over or running 2. So our slope would be rise, or 3 over 2. 3 over 2 would be the slope. And again, this is true no matter what triangle you add on here. From here to here is 3 over 2. And that's the only other point that you see on here at this point, but they would all be 3 over 2. In graph number 3, we'll try it again. Also uphill, so we should end up with a positive number, not negative. We are rising up 1, so plus 1, and we are running over 2. So our slope would be rise 1 over run 2, or 1/2. And again, you see this no matter where you are putting a triangle on this line. We're always going up 1 and over 2. So once you try number 4, start with the left-hand point and go up to the next point. Pause the video quick and see if we get the same thing. So hopefully you started here at the left, you traveled upwards, and I counted 5. We're going up 5, and we're running over 3. This is an uphill or a positive slope, so we should have a positive 5 over 3 as our slope, rise over run. Example number 5, same thing, starting with the left. This time we do have a downhill, so we should have negative. We're changing in y first, and to do that we're going down 3. So a negative 3 and running over 2 for a slope of negative 3 over 2. And lastly, our rise over run again is a negative here for graph number 6 because we're traveling down 2 and over to the right 2. So our slope would be negative 2 over 2, which we can simplify. We write it as fractions, or we keep it as fractions unless we can simplify. In this case, we know that this can simplify to negative 1. So really the slope of this line would be negative 1. And we know the y-intercept of this line as well. So really, at this point, we could piece together an entire equation because we know that all equations start with y equals something is being multiplied by x, and that's what we've been calculating. This m is what's being multiplied by x. So in this case, we have a negative 1 being multiplied by x, and it intercepts the y-axis at negative 3. So this equation is what is describing this graph, the number that's changing, rise over run, with the y-intercept at the end. So hopefully at this point you have seen enough of my slope triangles to get it here on your own. If for some reason you need to go back and rewatch, that's why I've made this in as a video. But if you turn the page in the little note packet that I gave you, you will see this, which we are actually going to skip for the time being. But that very third page, this is what our check-in is going to be for today. There's just 4 graphs. I know you see down at the bottom 5 through 8. I don't need you to do that. Just numbers 1 through 4 will count as your check-in for today. I'd like you to calculate the slope for each of these graphs. And if you're up for it, see if you can write me out an equation if you know what the y-intercept is. I know for graph number 2 we don't. But for graph number 1, you see where it intercepts the y-axis. Give it a shot. But at the very least, I should see a slope. So I should see what our rise is over our run. Then you can come check in with me, and we'll take it from there.